I'm Joe Kirshner with American Water College. Watch as I use my 5-step approach to solve this problem.
Let's take a look at the pumping formula for brake horsepower. So in this formula, we have brake horsepower is equal to head times gallons per minute times 8.34 times the specific gravity divided by 33,000, and then there's some units missing there. That 33,000 is a conversion factor. And then we divide it by the efficiency of the motor in the pump, or pump motor, whatever efficiency they give us. So this is basically our brake horsepower formula. The head is the elevation in feet that the pressure basically will raise the water in the pump. So head, the units will be in feet, and we relate it to this water level in a tank, for example. Gallons per minute is our flow rate. So this formula will give us the flow rate in gallons per minute. So we either need to enter our flow number in gallons per minute, or we can use this formula to solve for flow rate in gallons per minute. You can see that that's just basically this gallons per minute going from the pump station to the water storage tank. The 8.34 I skipped over, but it's basically the weight of a gallon of water. Now there's another formula that I often will use, in some other lessons I used it. If you take 33,000 and you divide it by 8.34, that gives you 3,960. So these two numbers can be reduced down so that the 8.34 goes away, and on the bottom, instead of 33,000, you'll use 3,960. So if you're familiar with that version of this formula, it's okay to use. You'll get the same answer. But this 8.34 is simply the weight of a gallon of water. Then the specific gravity is the specific gravity of water. Well, you can see the specific gravity of water is 1. And when you multiply anything by 1, it doesn't change it. So this essentially can be dropped out of the formula. Now, if we were pumping something other than water, like oil or some other substance that does not have a specific gravity of 1, we would have to use the specific gravity to come up with our brake horsepower. But since we're dealing with water, that specific gravity of 1 just can get canceled out. And then the other key in using this formula is this efficiency. The efficiency has got to be entered as a decimal. For example, if you have pump efficiency of 74%, then you would enter that as 0.74. Okay, so enter our efficiency as a decimal. Another type of problem that you might come across is friction loss. So for example, you might have 80 pounds per square inch coming out of your booster station, and as that water goes through the pipe and travels, say, a mile down the road, because of the friction within the pipe, between the water and the pipe, you're going to have some loss. So you might end up with 70 psi, so something lower due to the head loss due to friction. So just be aware of that. For the problem we're going to look at next, we don't deal with head loss, but it's possible that they'll tell you that you have 1 psi for every 200 feet of pipe. You're going to have to overcome that head loss, which increases the required head for pumping. So just be aware of that. Well, let's get into this pumping problem. This problem reads, calculate the flow rate in gallons per minute flowing through a pump that is pumping against 150 feet of head. Pump efficiency is 75%, shaft RPM is 1800, and brake horsepower is 50. So we're looking for our flow rate in gallons per minute. The head is 150 feet. We're 75% efficient. Shaft RPM is 1800 and brake horsepower is 50. So let's write all that down. So here you can see we've pulled these numbers with the units out of the problem. We've written them down so we can work with them. Okay, so we have all that. That is step 1. Step 2, we select our formula. And when working with a pumping problem, we're going to use formula. So go into our equivalent sheet, the horsepower formula that they give. It says horsepower is equal to head times gallons per minute times 8.34 times specific gravity divided by 33,000 divided by efficiency. So let's go back and plug that in. Okay, so we write down our formula. Well, we're looking for gallons per minute. Okay, notice right at the beginning it says calculate the flow rate in gallons per minute. And we wrote that down here. This unknown is always what we're looking for. Okay, so we're looking for gallons per minute. Well, it happens to be right here in our formula. So what that means is we have to rearrange this formula to solve for gallons per minute. Okay, so we'll do step 3 where we rearrange the formula. What that means is we're going to have to divide both sides by head, 8.34 and specific gravity. We have to multiply both sides by 33,000 and the efficiency. So using our diagonal rule, this head will move to the bottom of the other side. The 8.34 and the specific gravity will move to the bottom of the other side. This 33,000 and this efficiency will move to the top of the other side and multiply by horsepower. And that'll leave us with gallons per minute by itself. Okay, so let's see how that works. So the key here, and we have a lesson on working with formulas that goes into detail on how to rearrange formulas. So if you need to review that, I highly encourage you to do that. But basically what we did is we just moved things diagonally across the equal sign to isolate or get gallons per minute by itself. So you'll notice where the head was on top of this division line on the right side, it's now on the bottom. 8.34 and specific gravity moves to the bottom of the other side. These two values moved to the top of the other side, and now we multiply it by horsepower. And that leaves gallons per minute all by itself. So now that we have it rearranged, we can plug in our numbers and do the math. So plugging in our numbers, we have 50 horsepower times 33,000 times 0.75. Now our efficiency is 75%, but remember we enter that as a decimal, 0.75, divided by our 150 feet of head, the weight of a gallon of water, which is 8.34, and then specific gravity of water is 1. So you don't necessarily have to put that 1 in there. But plugging those into my calculator and hitting equals, I come up with 989 gallons per minute.
If you need additional help preparing for a state license exam, click the link below and we'll get you some more information about our license-specific exam prep courses.